This is the first section in chapter 5, which is all about forces. And just a quick recap, whenever we do any of these questions, quite often there won't be any forces drawn on the question. They may give you the size of certain forces, but you need to know what forces to put on a diagram. So for example, here we've got a book on a table, laying on a table like this. So one of the forces that's not on a diagram will be mg, the weight of the book. Let's say it has a mass of m, the mg pointing down. Why is this not dropping through the table or flying off up in the air? Is because we have a normal reaction. So the word normal means perpendicular. So a perpendicular reaction, if you like. And here we have, there's this pulling force here of F. It's being pulled in that direction. But because it's being pulled off at an angle like that, what we need to do is to split that force up into its horizontal and vertical parts. So this part of the force here that's going horizontally, that will be F cos theta, and the part of the force which is going vertically up here will be F sine theta. And depending whether this thing is not moving, in other words all the forces are balanced, or whether it's accelerating, will determine the equation. So let's say for example that this thing isn't moving and it's all in equilibrium. Now what does that mean? That means that any upward forces equal any downward forces, any forces to the left equal any forces to the right, or parallel and perpendicular forces. So this flat area here we call the plane. So let's look at the forces which are perpendicular to the plane, and those are going to be these forces perpendicular to the plane, the flat surface that it's lying on. So if we have a look, we have our forces going up are R and F sine theta. So that will equal the forces that go down, and that's just mg. So that would give us one equation. Okay. Now if we look at the forces parallel to the plane, that is the forces that are going left and right. If this was in equilibrium, those would be balanced. And so that would give you just F cos theta there, and you see there is no force going in the other direction. Okay, let's make this a little bit more realistic. Let's say that there is some friction here, and I'll use Fr for friction. So that, let's say that the book is moving or accelerating in that direction. We've got friction opposing its motion, so that would be F cos theta equals friction Fr. Yeah, that's if it's in equilibrium. Now let's say that it's accelerating in that direction, it's moving to the right. That means some of the forces will be unbalanced. So let's look at accelerating, and let's say it's accelerating in this direction. We should show acceleration with a double-headed arrow like that. Well, because it's accelerating in that direction, it means that the forces going this way are bigger than the forces going the other way. So if we do the forces going to the right and take away any forces going to the left, that is what we call the resultant force, and that will equal MA. However, it's not accelerating up or down, so the upward force still equals the downward force. So our first set of equations over here will be the same as before. R plus F sine theta equals mg. That's no different. But our equation for the horizontal movement, that will change. So that will become F cos theta minus friction equals MA. So that changed because the force is unbalanced and it's moving in that direction. So let's have a go at a couple of questions. So what we've got here are some diagrams, and it says find the component of each force in the X direction and the Y direction. Now we've done this before, this sort of triangle here, or if we've got a force going like that, and we want to find out what these two bits are. It's basically like a right angle triangle, and this angle is theta. This will be F cos theta in length, and this will be F sine theta in length. So we're going to be using a lot of that. So I'm actually going to draw on the diagram the two bits that I want to find. So all we're doing is we're treating a force like a vector. A vector has a start position and a finish position, and we're going from the start position to the finish position. We just happen to be going horizontally and vertically. So this part of the force here is going to be 9 cos 40, and we were in degrees. I think all forces questions we do in degrees, and this will be 9 sine 40. So we're going to work those out and give the answer to 3 significant figures. So part A, the X direction, so the first part of that is going to be 9 cos 40, so let's work that out. 9 cos 40 to 3 significant figures, that will be 6.89 newtons. And the Y direction, 9 sine 40. 9 sine 40. Now remember, we need to decide whether we need to put a plus or a minus in front of the answer, depending on whether that component of the force is going up or down. So that's going to be 5.785, so 5.79 newtons. And the third part of the question says write it in the form IJ. So all that's going to be is 6.89I plus 5.79J. Done. Okay, let's have a look at the second bit of the question. So we've got that component, that bit of force there, that bit there. This part of the force is going to be 100 cos 18, and this bit of the force here is going to be 100 sine 18. So let's now work those out. Part B. So we want the X part of the force. So the X component of the force this time is the sine part. So it's 100 sine 18. Okay. Now I'm going to write it as a, well, it's actually a force. I could write this as a negative or a positive. Really, when I do IJ, I'm definitely going to have the negative there. Let's put a negative, so minus 30.9 newtons. And the second part of the question, we do 100 cos 18, and we get 95.1, and also that's negative as well, negative 95.1 newtons because of the direction. So let's write this in the form IJ. So the I part will be negative 30.9 I minus 95.1 J. So that's done. Okay, so let's have a look at this question here. So the first thing you do is read through the question and see if there is any extra information that's not on the diagram. So we've got a box of mass 8 kilogram. Yep, it's on a smooth horizontal floor. Okay, so that means no friction. Yeah, so we don't need to worry about friction. A force of 10 newtons is applied at an angle of 30 degrees, that's on the diagram, causing the box to accelerate along the floor. Work out the acceleration. Okay, are there any missing forces? There is actually the normal reaction and the weight of it, but we don't actually need these in the question, or do we? Let's have a look. So let's split this force up into the horizontal and vertical parts. So this bit here will be 10 cos 30, and this bit here will be 10 sine 30. Right, so if it's accelerating, it's going to accelerate in this direction. Yeah, it's not going to move up or down, it's just going to move sideways. So if it's accelerating in that direction, it means that the bigger force has got to be the force that's going to the right, which is that. Okay, is there any force going to the left? No. So actually, using F equals ma, the resultant force is just 10 cos 30, and that equals ma, so 8a. So that means the acceleration is 10 cos 30 divided by 8. So let's work that out. 10 cos 30, divide that by 8, and we end up with 5 root 3 over 8. So 5 root 3 over 8 meters per second squared, or if you want it as a decimal, that is going to be 1.08 meters per second squared. Now, whenever you work out an acceleration, I would always be skeptical of an acceleration that's bigger than 10 meters per second squared. That's a very fast acceleration. I mean, if you're looking at a rocket or a bullet or something like that, yeah. But, you know, boxes sliding across floors or weights dropping, you know, that type of thing, the tension is going to be well below 10, 1, 2, 3, something like that. So always check your answer. Is it a sensible answer? Right, part B, calculate the normal reaction. Okay, so here we look at the vertical forces. These are balanced because it's not moving up or down. So the forces going up are R and 10 sine 30. That's going to equal the force going down, which is 8g. So we can easily solve that. R equals 8g, 8 times 9.8 minus 10 sine 30. And let's see what we get for R. 8 times 9.8 minus 10 sine 30. And we get 73.4. So 73.4 newtons is the normal reaction. So I'll just highlight the answers. That's part A, and this is part B. Right, okay, now this question, we actually have got two different ways in which we can do it. I prefer the way where we resolve forces. You're going to see that actually I think that is easier to do, more straightforward. Or we can use the triangle law to do it. A little bit more fiddly, but essentially we're doing the same thing. Now with the triangle law, what I want to do is to take, let's say I've got a force like that, force number 1 acting like that, and I've got another force number 2 that maybe goes like this, force 2. Yeah, so force number 2 basically carries on from where force number 1 finishes. Then the resultant of that force basically is the force that starts at the beginning of force number 1 and finishes at the end of force number 2. So that essentially is the resultant force, F1 plus F2. Yeah. Now, I've drawn the forces so that I get a triangle. But if you look at the question, there's no triangle. I'm going to make it into a triangle. What I'm going to do is I'm going to take this force Q down here and I'm going to slide it up so that it goes like this. It's still going to be pointing in the same direction, so it's still going to be parallel. It's still going to be the same size, but instead of starting here, it's going to start here. Yeah, so we can do that with vectors. We can move them around as long as they're pointing in the same direction and that they're the same size. So if I were to move Q so it's here instead, it's going to be something like that, then this is still force Q, so I've moved it from here, I've taken that and I've moved it there instead. This would still be 30 degrees, and then I want to try and find this force down here. Let's do a different color. So I'm trying to find this force here. That will be my resultant force. So that's all I'm going to do is move the force Q so it's just in a different place, but it's the same size and in the same direction. So I'm going to draw that diagram down here. So this is force P. Now in the question it says that it's 10 newtons. And I know it's 45 degrees from the horizontal. And then I'm going to draw force Q. Now force Q is going to be something like this. Okay, this is not to scale or anything. It's still 30 degrees below the horizontal, so the whole thing shifted up. And in the question that says that's 8 newtons. And this question is all about finding the size of that red arrow, the length of the red arrow, and the direction of that arrow. So I also need to work out what this angle is here. Now this is only a sketch. My force may not actually look that length, or it may actually be pointing up rather than down. It's just to help me do the working for this question. And actually it probably wouldn't look quite like that because the 10 is longer. It should be longer than the 8. So let's maybe make it a little bit more accurate so that we don't get confused. And all we'll do is we'll make that 10 longer than the 8. But the angles are different as well. So let's make this a bit longer, like that. And then the question is all about finding that thing there. Okay, so it's not meant to be accurate. It's just meant to help us visualize what's going on, so we can see what we need to work out. So actually that angle there is 45 degrees. So to find the length of that side, the one in red, I can use the cosine rule. If I'm going to use the cosine rule, it does mean I need to find the size of the angle between 10 and 8, the size 10 and 8, that's easy enough. Here I've got alternate angle, so that's 45. And if I take 30, that looks like 300, it's meant to be 30. If I take 30 away from, and 45 away from 180, I am left with, I think, 105. So 180 minus 45 minus 30, yeah, 105 degrees. So this is 105 degrees. So then we can use the cosine rule to find the length of this side. We'll call that side x. So x squared equals 10 squared plus 8 squared minus 2 times 10 times 8 times cosine 105. So that is 10 squared plus 8 squared minus 2 times 10 times 8 times cosine 105. That's 205.41, like that. So square root it. That's 14.3. Okay, so that's the size, the magnitude of the force. We now want to find the direction. So we probably want to find this angle here. Now, if we're going to find that angle, I know the whole of the angle from here round to here, all of that is 45. So if I can work out this bit, I'll highlight it in yellow. If I can work out that bit, I can just take it away from 45 to find the size of the angle. Now, if I get a negative answer, it just means that the angle is probably pointing downwards, but we'll have a look and see what we get. So if I want to work out the angle that I've highlighted in yellow, I'm going to use the sine rule now. So let's just put here that we use the cosine rule. So the sine rule. So I've got that side, I want to work out that opposite angle. I've got this side and I've got this side here and I've got its opposite angle. I'm trying to find an angle, so I'm going to put the angle at the top. So sine 105 over the opposite side, which is x, that's that 14.3, but I'm probably going to use the answer button, equals the sine of the, let's put the yellow angle, rather than put more letters in, over 8. Right, so if I do sine 105 divided by my previous answer, times that by 8, then do the sine inverse of that, I'll get 32.62, or 32.63. So the angle is 32.63. Right, so to find the bit that's in blue, that bit, I need to do 45 minus 32.63. So 45 minus my answer, I get 12.38. 12.37. Okay, so my final answer is that the size of the angle is 14.3 newtons and the direction of the arrow is 12.37. I'm going to put above the horizontal. Okay, can't see, it's 12.37 above the horizontal, yeah, or elevated from the horizontal. That took a lot of work. Let's do the same question resolving forces. No triangles involved, no moving of forces, so we'll clear this all off. And let's do it the resolving forces way. Now, if we're going to resolve forces, all we need to do, and you'll see, I think this is much easier. We work out the horizontal and vertical part of each force, and then we just add them together. Now, this is going to be positive because it's of its direction, so all that, This will be negative because of its direction. So let's look at the forces vertically. So what have we got going up now? P was 10, wasn't it? So let's put 10 here. Q was 8. So the one going up, that is going to be 10 sine 45. Is there anything else going up? No, we've got one going down. So that's going to be 8 sine 30. Okay, the total of that gives you the total of the horizontal force, and its sine will tell us whether it's going up or down. So you've got 10 sine 45 minus 8 sine 30, and I get negative, I thought I got a negative. Well, it was minus 4 plus 5 root 2, but actually when you press the SD button, I get 3.07. Okay, so that's basically telling us it's moving that amount up because it's positive. Right, so now let's look at the forces going horizontally. They're both going in the same direction, so I add them both. So I've got 10 cos 45 plus 8 cos 30. So if I add those together, 10 cos 45 plus 8 cos 30, and that gives me 13.999. So let's call that 14.0 newtons. And because that's a positive, it's going that way. Now what does that tell us? It tells us that the resultant force goes 14.0 across and 3.07 up. You could write it as 14I plus 3.07J, and all we want to do is to work out the size and direction of that. So if you want to work out the size of it, the magnitude of that force, we just do Pythagoras on it. So square root of 14 squared plus 3.0 squared, and hopefully we should get the same answer as the triangle way of doing it, the triangle law. So 14 squared plus 3.07 squared, I get 14.33, 14.3, same answer. And I think an easier way of getting the same answer, so the magnitude is the same. And then to find the direction, so we're basically finding this angle here to find a direction, just like we did before. The direction is going to be the tan inverse of 3.07 over 14.0. So let's do that. Tan inverse 3.07 over 14, and we get 12.368 or 12.37. So 12.37 degrees above the horizontal. Above horizontal. Right, so look, exactly the same answer, but it took me a fraction of the time to do it. So I would, unless you have to, I would try and avoid using the triangle law way of doing it and just resolve forces, because you use forces for resolving forces for pretty much everything else. I can't think of a situation where you would have to use the triangle law and you can't resolve forces. But I've put both ways there to show you, but you'll see that you get the same answer either way. So I definitely wouldn't be using the triangle law here. I would just split each force up into its horizontal and vertical components. Now you'll see what I'm doing here is drawing what they are, and I'm color coding it. And the question says that this is in equilibrium. Now what does that mean? That means the up forces equal the down forces, and the forces to the left equal the forces to the right. Okay, so what are those forces? Let's start with the forces which are going vertically. Right, okay, so what forces have we got going up? Let's see if I can color code this. So we have 140 sine 45 plus 100 sine 30. Okay, and then what do we have going down? We've got something where we're actually having to write the angle using theta. That's not a problem. That's going to help us to find theta and p, because we'll have two equations in a moment. And that's going to be, the one going down is p sine theta. Right, so that's equation number one. Now the 10 sine 45 plus 100 sine 30, let's see what that gives us. 100 sine 45 plus 100 sine 30. Okay, we get 148.994949. Let's call that 149. It's pretty much that. So that will give us the equation that P sine theta equals 149 newtons. Okay, so we've got one equation there. Now let's do the same going horizontally, like this. So again, I'll try and color code it. So it's all the stuff that's pointing to the left equals the stuff that's pointing to the right. So pointing to the left, we have 140 cos 45, and that's going to equal the two that are pointing to the right. So the blue one will be 100 cos 30 plus the other one pointed to the right will be P cos theta. Right, now that can be rearranged so that I take 100 cos 30 away from both sides. So if I do 140 cos 45 subtract 100 cos 30, okay, I get 12.39. So equation number 2 is that P cos theta equals 12.39. So this is equation number 2. So two equations, two unknowns. We can find P and theta quite easily. So let's finish this off then. Now, if I do P sine theta over P cos theta, the P's will cancel out. I'll have sine over cos, which is just tan theta. And tan theta is equal to, well, that was 149. So we're actually writing down what we get, 12.39. Okay, so theta equals the tan inverse of that. If I do that, 149 divided by 12.39, I get 85.25 rounded. So 85.25 degrees is theta. And if I want to find P, I just substitute that into either one of my two equations. So I'm going to sub in 85.25 into, let's say the first one, P sine theta. Okay, so sorry, equals 149. Equals 149. So that means that P times the sine of 85.25, I will probably use the answer button, equals 149. So that means that P is equal to 149 divided by the sine of 85.25. What do I get? 149 divided by the sine of my answer, and I get 149.51. So 149.51 newtons. Right, so I have P here and I have theta here. Right, you should now be able to do exercise 5A on pages 94 to 96 of the textbook.